Hello friends, welcome back to Positive Approach. This is Nitesh Bharadwaj. We are discussing about our Unit-4 work, power and energy. Yesterday we discussed our topic work and today we will going to discuss about our topic energy and tomorrow we will discuss our topic power. So without wasting any time, let's start. Yesterday we discussed all these key points. Now today we are here. What is mechanical energy? Mechanical energy is the sum of kinetic energy plus potential energy. Okay, now we will discuss about this kinetic energy. What is kinetic energy? Kinetic energy depend upon the, our first key point is kinetic energy depend upon mass and speed of object. Kinetic energy depend over mass and speed of object. Keep in mind, it does not depend upon velocity. It is depend upon speed of an object. Work done by the force to accelerate a body is equal to kinetic energy. Work done by any force which accelerate a body is equal to kinetic energy of a body. And this kinetic energy is a scalar quantity. Kinetic energy is scalar quantity and it is denoted by half of mv square, where m is the mass and v is the speed of a body, and the unit is same as that of energy. Its unit is same as that of energy, that is joule, and its unit is same as that of work, and its dimensional formula is ml square t minus 2. This is the SI unit of energy, kinetic energy, and dimensional formula of kinetic energy. Okay, our next key point of kinetic energy is kinetic energy having uniform circular motion remains constant. Work done by kinetic energy, work done by kinetic energy having uniform circular motion, having uniform circular motion remains constant. Work done by any kinetic energy having uniform circular motion remains constant, and kinetic energy of a body moving vertical, kinetic energy of a body moving this vertical circuit have maximum value at this point, and it is under root of 5 gr and minimum at its highest point, and this is under root of gr. The kinetic energy of a body moving in vertical circular path is maximum at its lowest point and minimum at its highest point. These are the some important key point of kinetic energy. Our next key point about kinetic energy is kinetic energy of an electron. Kinetic energy of an electron is measured in electron volt, and 1 electron volt is equal to 1.6 into 10 raised to power minus 19 coulomb. Kinetic energy of electron is measured in electron volt and its value is 1.6 into 10 raised to power 19 coulomb. And this kinetic energy of a body depends upon frame of reference. It depends upon frame of reference. I hope these all key points of kinetic energy are clear to you. Now, next, work energy theorem. Work energy theorem is given by half of mv square minus half of mu square. That is change in kinetic energy of a body. Change in kinetic energy of a body. If there is no change in speed of the body, then the work done by this kinetic energy is equal to 0. This is the work energy theorem. This formula is important. Later on, we will do some numerical on the basis of these formulas. Our next key point is work done negative if decrease in the speed of the body. If there is decrease in the speed of the body, then this work done is negative. If there is decrease in the speed of body, for example, if initially its speed is u and after some time its velocity is u and it is less than that of U. Then we say that work done is negative. Our next key point is relation between kinetic energy and linear momentum. Okay, this is very important lesson. We know that kinetic energy is half mv square, which is equal to 1 divided by 2 m multiplied by m divided by m into v square, which is equal to half mv square divided by m. We know that what is linear momentum? It is the product of mass and velocity, which is implies p square divided by 2m. So the relation between kinetic energy and the linear momentum is p square divided by 2m. This is very important relation. I hope this kinetic energy, all the key point and the formulas related to this kinetic energy is clear to you. Now let's discuss potential energy. Now what is potential energy? Potential energy depends upon the position of the object. It depends upon the configuration of the object, and it is denoted by mgh. I'm sorry, I forgot to tell you about this relation, force and kinetic energy. This relation is given by half of mv square minus half of mv square divided by some distance. This is the relation between force and kinetic energy. Now potential energy. Potential energy is mgh. This is also a scalar quantity. This is also a scalar quantity and same unit. Same unit as that of kinetic energy, that is Joule. Same unit as that of energy, that is Joule, and same energy as that of work done, that is Joule. And its dimensional formula is ml square T minus 2. This is potential energy. Now our next key point is water stored in dam possesses potential energy. Water stored in dam possesses potential energy, and when there is a restoring force alpha to the displacement and at its point direction always opposite to that of displacement, this is implies F is directly proportional to minus x. What does this imply? This implies restoring force is directly proportional to displacement but in opposite direction. So here F is equal to minus kx, and this relation is also called Hooke's law. This relation also called Hooke's law. Our next key point is work done by conservative force around closed path is zero. Work done by conservative force around closed path is zero. I hope these key points are clear to you regarding potential energy. Our next key point are, which are very important for potential energy, is relation between potential energy and potential energy conservative force. Relation between potential energy and conservative force. This is implies potential energy is equal to F. Relation between conservative force and potential energy function. This is implies F. This is conservative force, which is equal to minus del of U, or you may write it minus curly over curly xu. This is the relation between potential energy function and conservative force. And gravitational potential energy on the surface of Earth is zero. Gravitational potential energy on surface of Earth is zero. Why? Because we know that potential energy is equal to mgh, and on the surface of Earth height is zero. What does this imply? This implies potential energy is equal to zero. So potential energy on surface of Earth is zero. Now next concept of potential energy is elastic potential energy. The expression for elastic potential energy is given by half of kx square, where x is the distance where x is the distance and where k is spring constant. This is elastic potential energy half kx square, and this elastic potential energy can never be negative. Potential energy can never be negative, and this elastic potential energy increases when spring stretch or compress. This elastic potential energy increases whether spring is stretched or compressed. The elastic potential energy always increases and it cannot be negative. And SI unit of this elastic potential energy is also same as that of potential energy, as that same of kinetic energy, same of work done, that is Joule. And what is spring constant here? Spring constant here is K, which is equal to force divided by X, where K is equal to force divided by displacement, and its unit is Newton per meter. Newton per meter. This is all about elastic potential energy. And there is another important formula, that is elastic potential energy. EPE means elastic potential energy of an already stretched spring gauge. This is equal to half of K, where K is spring constant, into x2 square minus x1 square, where x1 and x2 are displacement of that spring. I hope these formulas are clear to you. Now, work done by conservative force. Work done by conservative force around closed path is equal to 0. And friction force is a non-conservative force. Keep in mind, friction force is non-conservative force because it depends upon path. And when an object is subjected to be vertically upward, then at this point, at its highest point, its all kinetic energy is converted into potential energy. At this point, its all kinetic energy of the object is converted into potential energy. I hope these all key points about kinetic energy and energy are clear to you. Now, we will discuss some numerical on the basis of these formulas. Let's start. Our first numerical is find kinetic energy of a bus having a mass. The mass of the bus is 10,000 kg and moving with the speed, and its speed is 30 meter per second. We have to calculate its kinetic energy, which is equal to half mv square. Now, half into m, 10,000 multiplied by 30 into 30. Now, 2 ones are 2, 2 fives are 10, 0, 0, 0, which is equal to 5 threes are 15, 15 threes are 45 into 10 raised to power 3, 4, 5, 10 raised to power 5 joule. This is the kinetic energy of the bus having a mass 10,000 kg and velocity 30 meter per second. Then this is its kinetic energy. I hope this numerical is clear to you. Our next numerical is a bus weighing 10,000 kg. The mass of bus is equal to 10,000 kg. Moving with velocity, and its velocity is 36 km per hour. Convert it into meter per second, which is equal to 10 meter per second, because 36 into 1000 divided by 3600. That is 36 into 1000 divided by 3600. So it is 10 meter per second. Now, how much retarding force is required to stop this bus in a distance of 50 meter? Here x is 50 meter. We have to calculate the retarding force. We have to calculate the retarding force which is required to stop the bus. We know that the relation between the force and the kinetic energy, if force into displacement is equal to half of mv square minus half of mv square, as we discussed earlier. Now here half of m v square minus u square, where v is approaching to 0. Now half m, what is the mass? Mass is 10,000 kg into 0 minus u square, where u is 10. 10 into 10, 100 with negative sign, divided by, here this is f, and divided by s, where s is 50 meter. Now which is equal to f is equal to 2 ones are 2, 2 5s are 10, 0 0 0, 0 cancel 0, 5 ones are 500, which is equal to minus 10,000 Newton. This is the retarding force required to stop the bus weighing 10,000 kV moving with velocity 36 km per hour. And this is the retarding force required to stop this bus in a distance of 50 meter. I hope the numerical is clear to you. Our next numerical is potential energy of a spring when stretched 10 centimeter is 5 joule. We know that the potential energy in case of spring is half kx square, which is equal to, this is 5 joule. This is 5 joule. Calculate the amount of work done to stretch it in an additional distance of 10 centimeter. We have to calculate its work done. We have to calculate work done to stretch this spring in an additional distance of 10 centimeter. In an additional distance of 10 centimeter. Here we get half kx square is equal to 5 joule. Okay, now the potential energy of a certain when stretched 10 centimeter, when here x is equal to 10 centimeter, which is equal to 0.1 meter. This is the potential energy half kx square when we stretch the spring in the distance 0.1 meter, then its potential energy is 5 joule. Now here substituting all these value, we get this, the value of k, which is equal to 5 joule multiplied by 2 divided by this x square, where this x square is 0.1 into 0.1, which is equal to 5 2s are 10 into 0 0, which is equal to, then the value of k is 1000 Newton meter inverse. This is the unit of this spring constant. Now we have to calculate the work done to stretch it in additional distance. Now additional distance, first distance is 10 centimeter plus additional distance 10 centimeter, which is equal to 20 centimeter, which is equal to 0.2 meter. Now the potential energy to stretch the spring with this distance of 0.2 meter. Potential energy half kx square, where half value of k is 1000 into x. Now 10 plus 10 is equal to 20 centimeter, which is equal to 0.2 meter square. Now potential energy is 1 over 2 into 1000 into 2 multiplied by 2, 4 divided by 100. 2 ones are 2, 2 2s are 4, that is equal to 20 joule. Now the potential energy of the spring is 20 joule. Now work done. We have to calculate the work done. Work done is new potential energy minus this old potential energy. Okay, now which is equal to work done. New potential energy is 20 joule and our old potential energy is 5 joule. So our new work done given by is 15 joule. So this is our right answer. The potential energy of a certain spring when stretched 10 centimeter is 5 joule. Calculate, this is the amount of work done. This is the amount of work done when we stretch a spring of additional distance of 10 centimeter. I hope this numerical is clear to you. Our next numerical is a block of mass 20 gram moves along a smooth surface at speed of 5 meter per second. What is the mass of block is 20 gram, which is equal to 20 into 10 raised to power minus 3 kg. Along a smooth surface at speed, what is the its speed is 5 meter per second, collide with the spring at a constant of 20 Newton meter per meter. Spring constant is 20 Newton meter inverse. Find maximum compression of the spring. Find maximum compression of the spring. Here we have to find this maximum compression. For example, here this is a block and this is a fixed spring. When we collide this box with this spring, then we calculate the compression of this spring. So in fact, in a normal layman language, we have to calculate this distance x. Okay, now we know that the spring constant is 20, then the potential energy is half kx square. This is the potential energy of a spring, which is equal to half into 20 into x square, which is now potential energy of this spring is 10.kx square. Like this will be question number 1. Okay, now a block of mass 20 gram moves with a smooth surface at a speed of 5 meter per second. Then the kinetic energy of this box is half mv square, which is equal to kinetic energy of the body, that is equal to half into mass is 20 into 10 raised to power minus 3 multiply by v square. 5 5s are 25, 2 1s are 2, 2 10s are 20, which is equal to 25 into 10 raised to power minus 2, which is equal to 0.25. 0.25. We know that energy is always conserved. At this point of collide, this kinetic energy will convert into potential energy. So by applying the conservation of energy, this potential energy is equal to kinetic energy of the body, and here the kinetic energy is 0.25 and potential energy is 10.x square, where this x square is equal to 0.25 divided by 10. Here this x square is equal to 25 divided by 100 into 1 over 10, where this x is equal to under root of 25 divided by 100 into 1 over 10, which is equal to 5 over 10 into 1 over under root 10. 5 on the 5 2s are 10. X is equal to 1 over 2 under root 10 meter. This is our distance. I hope all these numerical and all these key points are clear to you. This is all about our energy. Now, tomorrow we will discuss about power, their key point and important numerical. Thank you and have a nice day.